Hello everyone. Today we are diving into thermochemistry. This is the branch of chemistry that deals with heat, energy changes and chemical reactions. So, have you noticed why some reactions feel cold while other reactions release heat? That's because reaction either absorb or release energy. So, we shall explore key concepts from the chapter of thermochemistry. And let's get started with some important multiple choice question to test your understanding of thermochemistry. Question 1 is, if an endothermic reaction is allowed to take place very rapidly in the air, the temperature of the surrounding air. Here are four options given. You have to choose the most appropriate option. Option A is remains constant. Option B is increases. Option C decreases. And option D is remain unchanged. So, in an endothermic reaction, heat is absorbed from the surrounding. This means that the reaction takes heat from the surrounding air. So if the reaction happens very fast, it will quickly pull a large amount of heat from the surrounding air. As a result, the air loses heat and its temperature decreases. So the correct answer is option C, decreases, because the air is giving its heat to the reaction, making the air cooler. And now second question is, in endothermic reactions, the heat content of the. Here are four options. Option A is products is more than that of the reactants. Option B is reactants is more than that of the products. Option C is both the above A and B options. And option D is reactant and products are equal. So what would be the answer to this question? When we are talking about endothermic reaction, we see heat is absorbed from the surrounding. So this extra heat energy is stored in the powders. Since the powders have gained heat, their energy, that is heat content, becomes higher than that of the reactants. That's why the correct answer is option A. Powders have more heat content than reactants because they absorb energy to form new substances. And now question 3 is, calorie is equivalent to. Here are four options. Option A is 0.418 joules. Option B is 41.84 joules. Option C is 4.184 joules, and option D is 418.4 joules. So what is the correct answer to this question? Here is a simple relationship between the units of energy, that is between the calorie to joule, and we know that 1 calorie is equal to the amount of heat needed to raise the temperature of 1 gram of water by 1 degree centigrade. And we also see that joule is another unit of energy, and the scientists have determined that 1 calorie is equal to 4.184 joule. So this means that 1 calorie is equal to 4.184 joule of energy. So the true answer for this question is option C. And now question 4 is, the change in heat energy of a chemical reaction at constant temperature and pressure is called. Four options are given. Option A is enthalpy change. Option B is heat of sublimation. Option C is bond energy. And option D is internal energy change. Here look at the given options and we see that the option A, that is enthalpy change, is best answer to this question because the reaction is taking place at constant pressure. And when we talk about the heat change at constant pressure, then we should have to remember that it is the enthalpy change. And now question 5 is, which of the following statements is contrary to the first law of thermodynamics? Option A is energy can neither be created nor destroyed. And option B is one form of energy can be transferred into an equivalent amount of another form of the energy. And option C is in an adiabatic process the work done is independent of the path. And option D is continuous production of mechanical work without supplying an equivalent amount of heat is possible. As we have seen that this question is from the first law of thermodynamics, so the first three statements are actually the statements for the first law of thermodynamics, and the option D, that is continuous production of mechanical work without supplying an equivalent amount of heat, is possible. This is contrary to the first law of thermodynamics, so the right answer is option D. And now here question 6 is, for a given process the heat changes at constant pressure, that is QP, and at constant volume, that is QV, are related to each other. And here are the four options. Option A is QP is equal to QV, and option B is QP is less than QB, and option C is QP is greater than QB, and option D is QP is equal to QV over 2. For the given relationships, we have to understand that QP is equal to heat at constant pressure and QV is equal to heat at constant volume. So, at constant pressure, work can be done by expanding gases like in an open container. This means more energy is needed as compared to the reaction in a fixed volume like a sealed container. So, since energy is used for both heating and expansion at constant pressure, so we get QP is greater than QV. The correct answer is option, that's QP is greater than Q. And now we are on question 7, and the question is, for the reaction NaOH plus HCl gives NaCl plus H2O. This is the reaction. The reaction is neutralization process in which we have seen that base reacts with acid to form salt and water, and the change in enthalpy is called. Option A is heat of reaction, option B is heat of formation, option C is heat of neutralization, and option D is heat of combustion. As we discussed that this reaction is about the neutralization process, so option C, heat of neutralization, is the proper answer to this question. And now question 8 is, the net heat change in a chemical reaction is seen whether it is brought about in two or more different ways in one or several steps. It is known as, option A is Henry's law, option B is Joule's principle, option C is Hess's law, and option D is law of conservation of energy. So the option C, Hess's law, is the appropriate answer for this question, because this explains the heat change for a reaction which is brought about in two different routes. And now question 9 is, enthalpy of neutralization of all the strong acids and strong bases has the same value, because option A is neutralization leads to the formation of salt and water, and option B is strong acids and bases are ionic substances, and option C is acids always give rise to H positive ions and bases always furnish OH negative ions, and option D is the net chemical change involves the combination of H positive and OH negative ions to form water. As we discussed in multiple question number 7, for the neutralization process to help, that is the reaction between NaOH and HCl. So the reaction involves a base and an acid. So as we know that neutralization is the process in which H positive ion from the acid and OH negative ion from the base combine to form water. So the option D, the net chemical change involves the combination of H positive ion and OH negative ion to form water. This is the true answer for this question.